Here's the second part of Calculus Chapter 3, Section 3. So I'm going to label it B. And what we're going to do is a mix of all the different rules. So what we can do is, if you look in this problem, is we have a product rule mixed with a chain rule. And it's just going to take some practice, trust me, that you have to identify what's the big thing. So sometimes the big thing is the power rule, or chain rule, excuse me, and then we have the product inside. On this problem, the big thing is the product, so you want to do the product rule first. So I'm just setting it up. That one day I talked about how you can write 4 things down. So the derivative of 5x is 5. You leave that x plus 3 to the 1/2 power alone. I guess I should have reminded you that to the 1/2 power is the same as the square root. And then leave 5x alone. And then do the chain rule, which is bringing that 1/2 in front. Leave x plus 3 alone to the negative 1/2 power. And then times by the derivative of the inside, which is just 1. So that was actually probably a waste of time. So the derivative we're looking at, I'm just going to leave it as 5, the square root of x plus 3. Plus this one you could actually simplify to 5x over 2 square root. That's a bad square root. Let me fix that. Because it's the 1/2 power, it's the square root. The negative puts in the denominator, x plus 3. Let me pull up the answer key to verify that you could simplify this further if you want. So you can see where I stopped right here, right where you see the red work. But if you really want to, you could then continue on. And again, this person does the work a little bit differently than how I would. But you can see how it simplifies. So again, pause the video, soak this in, make sure you understand. Because when do you stop, really? You know, like if you're looking down here, do you really need to factor out the 15? Because nothing special happens. So it's sort of a preference on when you want to stop. So I'm just sharing this with you to help you out. Because a multiple choice might ask you to do all of this work. And I'm going to go back to my notes. So the next one. All right, so what's the big thing in this problem? So there's definitely a quotient and there's a chain rule because there's a function inside of a function. Well, if you notice, the quotient is inside. It's the inner function. So that's my clue to say that the outer function, so this is a chain rule first. So you want to do the derivative of sine, which is cosine, and you leave the inside alone. But then you need to multiply by the derivative of the inside, and that is your chain rule, where you do the derivative of the top, leave the bottom alone, minus the derivative of the bottom, leave the top alone, all over the denominator squared. Now this one I think it's worth the practice to simplify. You can't really do anything with this cosine of 2x plus 1 over x minus 3. But as I'm looking at the numerator on this, you can distribute the 2 in there. So you're looking at 2x minus 6. Let's see, that's minus 2x minus 1. So these would actually cancel. And what you're looking at is this quantity of negative 7 over x minus 3 squared. So this is how I would label my answer. But notice we can do multiple rules at once. Chain rule with the product, product with the chain, quotient with the chain, quotient with the product. And you've already seen a problem where you have a chain inside of a chain. Okay, so this one is really the same thing. You have a quotient with a chain rule. You might not see the chain rule yet. Oh, there it is. But now if you notice where the chain rule is, the big thing for h in this problem is to do the quotient rule. So now when you do the derivative of the top, that's where your chain rule is located. So notice I did the 1/2 in front to the -1/2 power times the derivative of the inside is 2, and then times the denominator. Just leave that alone. Minus the derivative of the bottom, which is just 1. And then just leave the top alone, at 2x plus 5 to the 1/2 power, all over the denominator squared. Now we can for sure simplify this at least a little bit, like this 1/2 and this 2 would cancel. I don't know if you really want to do anything else. I do know that the answer key takes it a lot of steps further, so I'm just going to share that with you. But again, when do you stop? It's tough to say. So let me share that answer key with you. So all of his work is the same as mine, but then what he does is he gets the same denominators in the numerator, because don't forget, if you have something to the -1/2 power, it gets into the denominator. So multiply top and bottom by the square root of 2x plus 5, so you can combine things together. What you'll actually notice is this numerator cancels. And then this step down here, instead of dividing by x minus 3 squared, that's the same as multiplying by the reciprocal, 1 over x minus 3 squared. And then as you distribute that -2x plus 5, I said they cancel. I'm talking about the square roots cancel. That's why the 2x plus 5 is still there. And yeah, I think it's all pretty straightforward from that. So again, let me scroll up a little bit more here. And I'm going to go ahead and pause the video if you want to simplify this all the way down, which I think is good. But where do you stop? It's tough to say. So let me go back to our notes. So in this problem, obviously we're going to do more with the chain rule than just what we've established. So what I would do, if we're trying to find the equation of the tangent line at x equals -4, don't forget that you need the point. Well, what we have so far is -4 is the point. Now be careful, because what we're doing for the y values, we're plugging -4 in for this x. So h of -4 is +4. So p of -4 is equal to the square root of +4. I hope that makes sense. So the y value is 2. Square root of 4 is 2. But now what we need to do is find the slope. Well, how do we find the slope? Yeah. Switch over. It's the derivative of p. Okay, well, let's refresh for a second. P of x is really equal to h of x to the 1/2 power. So I hope you can see the chain rule where you bring the 1/2 in front. You leave h of x alone to the -1/2 power. I hope you can see the power rule happening there. Leave h of x alone times h prime of x. So now, let me switch back to orange. When we do p prime of -4, because that's how we find the slope, it's 1/2. We already found h of -4 earlier. H of -4 was 4. So remember that with a negative exponent, it puts into the denominator, and we have to square root that. And now h prime of -4 is just saying, well, what's the slope of the h function? Well, the slope looks like it's going down 1 right 2. So that slope looks like it's -1/2. So as I'm looking at that, it's 1/2 times 1/2 times -1/2. That looks like -1/8 to me. 1 times 1 times 1, 2 times 2 times 2. Yeah, so now we have enough information. We switch it back to that other color to write the equation is equal to y equals the slope, and then x minus your x coordinate, so +4, and then plus the y coordinate over here is the answer we're looking for. So pause the video, soak this in, and now we can apply the chain rule to tangent line functions. So I'm going to go to the next page and finish these notes. So here's another problem where they define h of x. You've probably seen this table before. I feel like it's been familiar. We've done this several times. So how do we determine if something's increasing, decreasing? or relative min or max is finding the derivative. Well, how do we find the derivative of this chain rule? I guess I should have said the composition. It's the chain rule, where it's the derivative of f, leave g alone, times the derivative of g. So now we need to figure out what's h prime of 3. Well, it's f prime of g of 3. Well, what is g of 3? G of 3 is 4 times g prime of 3 is 6. Well, what's h prime of 4? H prime of 4 is 8. So we are looking at 8 times 6, which is 48. All we care about, though, in this question is that the derivative is greater than 0. So what does that mean? That h of x is increasing at x equals 3. And if you're asking where my reason is, it's all of this work, but I'm just highlighting h prime of 3 is greater than 0. And these equals just show the work that lead to that answer. All right, very good. Let's look at the next problem. So if we're trying to find p prime of 1, well, first let's find p prime of x. Now this is a composition function because the outermost function is g, so g prime of 2x. But then you have to multiply by the derivative of the inner function, which is 2. So now when we do p prime of 1, we have to do g prime of 2 times 1, which is 2, and then multiply that answer by 2. So look on your function, what's g prime of 2? Looks like it's negative 1. When you multiply it by 2, you get negative 2. And throw out one more problem at you. Define it as q of x, and we want to find q prime of 4. So let's start by finding q prime of x. I hope by now you're familiar that this is to the 1/2 power. That's going to happen a lot. So the derivative will be bring the 1/2 out front. It's now to the negative 1/2 power. You leave these functions alone inside, f of x plus g of x. But then you need to multiply by the derivative of the inside function, which is just the sum rule, the derivative of the first plus the derivative of the second. So now we can actually figure out what q prime of 4 is. So I'm assuming that you're good with the negative power sticks into the denominator. So now I need to figure out what f of 4 is and g of 4. Well, f of 4 is 1, and g of 4 is 7, sorry. Kind of getting ahead of myself, because then you add those values together. And then times that by the derivative of each. So f prime is 8, g prime is negative 2. So when we simplify that, I hope you're familiar with let me just show the scratcher. Square root of 8, 4 and 2, 2 and 2. So this would be 4 root 2, because 2 times 2 root 2. And in the numerator, 8 plus negative 2 is 6. And if you want, you can simplify it just dividing both by 2. Or if you prefer to rationalize it, we're looking at 3 root 2 over 4. Any of these answers work, and they're all accepted. So all that means, what does the value of this say for q of x? Well, it's a positive number, so q is increasing at x equals 4. So if you need to pause the video, now's the time to do so, because you should be ready for the homework now on the next page.